If we quickly recap on the idea of a data dictionary from the last lesson, we covered field names, types, and suggested field size, but we didn't really go into format. Went a little bit of validation, not very much, and we didn't do anything but key constraints. So the purpose of this lesson is just to go through those three things in the data dictionary, and then look at the entire structure of the database table as a whole, and think about whether it's appropriate to have all of the information about a particular collection of items in the same database table, or whether we need to split them into two or more separate tables. So let's start by looking at the format. So format allows you to force the person entering data into the database to follow a specific pattern for entry of data. So I've given you a little example of our pets database created electronically. And we've added a new column here for pet ID, which will become important later on, and the three that we talked about in the previous lesson. But let's focus on pet ID here. So as you can see, the individual pet IDs are 3 digits, and they all follow a specific pattern. So for pet ID, the format is that there must be 3 numbers. They're not optional, there must be 3 numbers. So if we want to force this, we set the format to be 0, 0, 0. And that means that there should be a number between 0 and 9 for each of the spaces given. Other format rules you can include are 0, which we said already must be a number, 9, which is an optional number, so it could be ignored, L, which denotes that there must be a letter in that place, and question mark, which is an optional letter which may be ignored. And this is particularly useful in the cases of, for example, postcodes, where we might have a format in the form of LL090LL, which means there must be a letter, must be a number, might be a number, then a space, then you must have a number, then you must have a letter, and you must have a letter. And so that covers the format. But on the next page, we're going to look at some of the different validation rules you can include in your data dictionary, and also talk about those key constraints. So let's look at our data dictionary in a bit more detail. And we're trying to fill in the last 2 columns of our data dictionary, the key column and the validation column. And you'll recognise that this is a slightly different layout from the other video, because I've now formalised that we should have field size and format, key and validation as separate pieces of information about that field. And we'll use this example database to try and fill out any validation that we require. Speaking about requirements, one of the validation checks that we can have in a database is whether a field is essential or not. So for example, with name, we don't want a pet without a name, so we can force the user to enter a value for name. And we signify this by using the word required in our validation table or column. So if we are building the database and we see that a field is required, then that means that the user must enter information, and we can set some validation to ensure that if they try and leave it blank, it displays an error message and asks them to enter a value. So there's any one of these columns that we can leave out, we don't mark it as required. So for example, we don't have any photographs for the 3 pets, and that means that the photo row in our data dictionary won't have required under the validation column. Another column that might not have a value is last checkup, because maybe that pet has never been to the vet. And if that's true, then maybe inoculations could be blank as well. However, it seems that we must have yes or no. So we'll just say that photo and last checkup are the only two fields which are not required. And let's fill up our data dictionary accordingly. Next, let's think about the key column. So if we had to uniquely identify this record, there's a couple of fields which might be useful when we're trying to find information about Rosie the cat. One is pet ID, because pet ID 1 is unique to that record. But then also, so is the name Rosie, and the fact that she's a cat, and the fact that she is 14 years old. You could even say that prefers fish is a unique field. And the last checkup is unique as well. Has inoculations, as you can see, is not a possible key because there are two records with Y. And so this stops has inoculations from being a unique way of finding Rosie the cat. So these potential key fields are called candidate keys. And this is a field which might be used as a primary key. But to find an actual primary key, which is a field which uniquely identifies a record, then we can start looking at these candidate keys and ruling out the ones which have the potential to have duplicate values under their headings. So, for example, if we look at last checkup, over time we might have lots of pets which come for checkups on the same day, in which case that is no longer unique. We also might have lots of pets which are the same age, so that rules out age. And we also might have lots of pets which are cats or dogs or hamsters, so that rules out type as a as a primary key. There is a smaller chance that you might have pets with the same name. So that rules out name. And of course, cats, there might be more than one cat that likes fish, there might be more than one dog who likes sausages, there might be more than one hamster that likes sausages, so we can rule out prefers as well. And through this process of elimination, we can narrow it down to pet ID because it's a numeric ID and it's unique to that particular pet. And so in this instance, the primary key is pet ID, and we denote that in the data dictionary by putting something called PK, short for primary key, in that column. So we have our single table database, as you can see here, and it can increase in size over time. And because we've identified that pet ID is the primary key, as long as we don't have more than 999 pets in our database at any one time, it's going to be fairly straightforward. We hold information about the pet, their age, and what they like to eat, and whether they were checked up or not and had the immunisations or not. We might even have a photograph of the pet. But what if we wanted to increase the amount of information we stored in our database to include information about the vet that they saw, the address that they live at, or the owners live at, and the names and the contact details of the owners? If we've got all this information, updating our database and keeping the integrity of our database consistent is really difficult. So for example, if we decided that we were going to update Nate's telephone number, for example, from 671349 to 123456, we would have to update it in multiple records in order to keep the data integrity intact. Similarly, if we have lots of vets, okay, and they've got their vet IDs, as you can see there, but also their names, and we get Bob's name wrong, for example. What if he wanted to be called Robert? Then we would have to change it in 2 different places. And if you scale this up to a database that maybe has 400 records in it, because a vet surgery would deal with lots and lots of different pets, they maybe don't have that many vets, but they have lots of pets. Updating this information becomes very time consuming and very easy to make a mistake. Another consideration is, what if the vet leaves? So if we've got information in our database and the vet Sam moves on to another practice, we can delete Sam from the database. But if it's in a single table, that also means deleting everything about that pet and the owner from the records. And this is bad because obviously that pet might still come to the vet surgery and that owner may have more than one pet. So if we delete it from the database, then that interferes with other information that might be useful to keep. That's the second problem. A third problem is, what if we want to insert another owner in the future? And that owner might have similar information. For example, the owner might also be called Mia. Now they can have a different owner ID, but if we're not careful, there might be a problem in linking this Mia to another person's pet in future. So the easiest thing to do is to split this up into different tables. And if we just sort of draw our battle lines, everything up to this point here could be in one table. All the information about the vets could be in another table, and all the information about the owners could be in a third table and linked together in such a way that we reduce the amount of information that needs to be updated manually. And we're going to learn about this in the next lesson.